Now let us discuss the significance of balanced chemical equation, right? Till now we discussed what is a balanced chemical equation, how can we balance a chemical equation, and how can we make balanced chemical equation more informative, right? By adding physical state, heat changes, precipitates, conditions, etc. And now let us understand what extra information a balanced chemical equation give us, okay, than a word equation. We write word equation, right? Zinc reacts with HCl hydrochloric acid, gives rise to zinc chloride plus hydrogen. We can write a word equation, but this balanced equation is more informative than a word equation. Let us see what information we understand from this balanced chemical equation. So firstly, we write first thing, number one, we understand what are the reactants and what are the products. The names of the reactants and products we understand. When we have a knowledge of chemical formulae, we understand the names of the reactants and products. In this equation showing here, what is the reactant? Zinc is a reactant. Second reactant is hydrochloric acid. Because we know arrow mark is generally separates reactants and products. Left side of the arrow mark reactants, right side of the arrow mark products. Zinc and hydrochloric acid are the reactants. Zinc chloride and hydrogen are the products, right? So first thing, what is it? First we understand, let me write here, we understand names of reactants and products. Names of reactants and products is understand from the chemical equation, from a balanced chemical equation. Second, what else we understand? We also understand, if I write, for example, if I write zinc chloride name, and from the zinc chloride name, we cannot understand what are the different elements present in it, rather, like, unless you know the chemical formula, right? If we write chemical formula instead of writing its chemical name, ZnCl2, then we understand two elements are present in zinc chloride. They are zinc and chlorine, and moreover, the number of atoms of each element present in one molecule of the reactant and product. Anything, it can be reactant or product is understand. So second one, what is it? We also understand names and number of atoms. Names and number of atoms of each element involved can be understood from the balanced chemical equation, right? It is balanced chemical equation, one zinc, two chlorines, two hydrogens, okay? So names of the reactants and products, and names and the number of atoms of each element. What are the elements here? Zinc is one element, hydrogen is second element, chlorine is the third element. Names of the element and also number of atoms of each element. Okay, we say one zinc atom, two hydrogen atoms, two chlorine atoms, right? Reactant side, the same number of atoms, product side, names and the number of atoms, right? And third one, what else we understand is third one, number of molecules of each reactant and products. Each reactant and products can be understood from the balanced chemical equation. So here from this equation, I write zinc coefficients. We have to look at the coefficient. What is the coefficient here? There is no number, which means what we understand? We understand there is 1. Here 2 coefficient. There is no number here, which means 1. And here there is no coefficient. We imagine it is 1. Now we write one atom zinc reacts with two molecules of hydrochloric acid to give out one molecule of zinc chloride and one molecule of hydrogen. So these are the number of molecules of each reactant product. Understand, one atom, two molecules, one molecule and one molecule, we understand. And next, fourth, we also understand instead of molecules, this balanced equation also gives the relative amounts of reactants and products in terms of moles, not just number of atoms and molecules. We also understand number of moles number of moles of each reactant and product, because product. Let us write how, right? This zinc, the coefficient is 1 here, which means it is 1 atom, or we can also write it as 1 mole substance. 1 mole substance, or we can write it represents 1 mole zinc, and this is 2 moles, 2 mole HCl, then it is a 1 mole zinc chloride, and this is 1 mole hydrogen, right? We understand number of moles, we understand. And also, like in each mole representing Avogadro number of particles. So here 1 mole, so I write here, if I write 1 mole, so generally 1 mole represent 1 Avogadro number, which is nothing but 6.02 into 10 to the power 23 atoms. 23 atoms. So 1 mole, 1 into 6.023 into 10 to the power 23 atoms, because you learnt in mole concept, 1 mole is the amount of substance that contain Avogadro number of particles. So if I write 1 mole zinc, that contain Avogadro number 6.02 into 10 to the power 23 atoms of zinc, and here 2 moles, 2 into this number is called Avogadro number Na. So here 2 Avogadro number of molecules, right? 1 Avogadro number of atoms of zinc reacts with 2 into Avogadro number of hydrochloric acid molecules to produce 1 Avogadro number of zinc chloride molecules and 1 Avogadro number of hydrogen molecules, right? We understand number of atoms or molecules like particles, next number of moles, number of total particles in 1 mole we understand, right? So number of moles, then we also understand volumes of gases, volume of gases at STP, So here any gas involved here, hydrogen is a gas involved, and this one volume of gases, volume expressed only for gases, that too at STP conditions. So here if I write this hydrogen gas at STP condition, it occupies 22.4 liters of volume. Okay, this is applicable, this is only for gases, it's only for gases, okay, or gaseous reactants and products. We can use it, what? Volume. Okay, at STP, so I'll write what is STP. STP stands for standard temperature and pressure. Standard temperature and pressure. Okay, the temperature is 0 degree Celsius, or we also write it as 273 Kelvin. Then the pressure is 1 atmosphere normally, or we also represent it as 760 mm of mercury. Okay, this is the unit expressing pressure. Okay, these conditions are generally called standard temperature and pressure, right? And we have a concept called gram molar volume. Gram molar volume, which means 1 mole of any gas, it can be hydrogen, oxygen, nitrogen, carbon dioxide, right? Sulfur dioxide, hydrogen sulfide, sulfur dioxide, any gas, methane, butane, propane, like any gas you take, at these conditions, at STP conditions, 1 mole of any gas, it occupies 22.4 liters of volume. This is called gram molar volume. So we also write what is the coefficient here? 1 H2 means 1 mole H2. This 1 mole H2 at STP condition occupies 22.4 liters. Okay, this is applicable only for gases, right? This is the interpretation or significance of a balanced chemical equation, right? Let us see here once more. This equation gives us all this information, right? Number of atoms or molecules of reactants and products, number of moles of reactants and products, number of particles present in given moles of reactants and products, or volume of the gaseous reactants and products at STP is also understand from this equation. right? Now let us see one more example and understand all these terms and how can we interpret a given chemical equation. Let us discuss another example to interpret this chemical equation, and we get what more information we get it from this chemical equation. So here is this chemical equation representing combustion of methane gas. What is this? The CH4 gas is called methane. Its common name is a marsh gas because it is produced at marshes. It's called a marsh gas or biogas, right? Methane. When this methane gas burns with oxygen, it produces carbon dioxide and water. And you can see all these reactants, all the substances, reactants and products are gaseous substances only. Okay, methane gas, it's a biogas, oxygen gas produces carbon dioxide gas, and water vapor which is in gaseous form. Now let us understand more information from this. What do we understand from this is, firstly, what is a coefficient? We just rely on the coefficients. First coefficient is 1, which means I write this is 1 molecule. 1 molecule CH4 needs 2 molecules of oxygen for complete reaction, for complete burning. You see, 1 molecule of CH4 needs 2 molecules of oxygen, and that produce only 1 molecule of carbon dioxide and 2 molecules of water. Okay, this is a primary information we understand from this. Okay, balanced chemical equation. Methane reacts with oxygen, produce carbon dioxide and water vapor. Right, 1 molecule of methane, 2 molecules of oxygen, 1 molecule carbon dioxide, 2 molecules of water. Right. We also understand, what else we understand? We also understand, instead of molecule, for convenient, molecule is very smaller particle, right? We cannot, represent the amount in molecules. So the convenient way of expressing amounts of reactants or products is their moles, number of moles. So here the coefficient is also equal to number of moles of that particular substance. 1 molecule of CH4, or we also write 1 mole CH4. This need 2 mole oxygen, that produces 1 mole carbon dioxide and 2 mole water vapor, right? And we also know 1 mole of substance weighs equal to its gram molecular weight, right? For example, 1 mole methane, if I take, what is the weight of 1 mole methane? 1 mole methane, so I write here molar mass of a substance is also equal to its gram molecular weight, right? If it is an element, if it is a monoatomic element, then we represent its gram atomic weight. Molar mass is equal to gram molecular weight or gram atomic weight. In case of metals or noble gases, molar mass is equal to gram atomic weight. But here in this equation, we see all compounds where oxygen is there, but this oxygen is diatomic, not monoatomic. So for this also, molar mass equal to gram molecular weight. This is an important condition to remember, which you have learned in 9th class, right? Now 1 mole CH4, molar mass means a mass of 1 mole substance. 1 mole here methane, what is its gram molecular weight? Carbon 12, 4 hydrogens 4. 12 plus 4, 16 gram. 16 gram, it is a gram atomic weight or molar mass of methane gas. So 16 grams of methane reacts with 2 times of oxygen, gram atomic weight is 32, 2 times of 32 grams. So let's understand, this is 16 grams of methane. It needs 2 into 32 grams, which means 64 grams. 16 grams of methane needs 64 grams of oxygen for complete combustion. And that produces what weight? 44 grams. 1 mole, right? 1 mole weighs equal to 1 gram molecular weight. 44 grams of carbon dioxide and 2 times 18 grams of water. 18 grams of water. These are the, we call these weights are stoichiometric quantities. These weights are called stoichiometric quantities. Stoichiometric quantities. So what is this word? This word has come from stoichiometry. It is a branch of chemistry. Okay, stoichiometry. It has came from two words here. One is a stachyon, second one is metron. Stachyon means elements, metron means measurement. So stachyon, elements and measurement. So quantity of elements measuring is generally called stoichiometry, and thus these quantities that we obtain from balanced chemical equation are generally called stoichiometric quantities. So stoichiometric quantities, 16 grams of methane. From this what we understand is 16 grams of methane require 64 grams of oxygen for completely burning and produces 44 grams of carbon dioxide and it's 36 grams of water is produced, right? These are called stoichiometric quantities, and these coefficients you see this what is it here, Nana? It is 1 here, this is 2, and this is 1, this is 2. These 1, 2, 1, 2 are generally called stoichiometric coefficients. Right? Using this stoichiometric coefficients, we obtain stoichiometric quantities. These stoichiometric quantities are very much helpful in estimating the amounts of reactants required and also the estimating amount of products produced that are obtained from a chemical reaction. Now let us understand, how these stoichiometric quantities are more important to us, right? If these stoichiometric quantities are used like this, now from this, for example, what I want is, if I take 8 grams of methane, or else if I take, let's see, let us also continue this after we shall discuss some examples. Now 16 grams, it is 64 grams, 44 grams and 36 grams. So we also understand this is 1 mole, this is 2 mole, this is 1 mole, this is 2 mole. Now we also know 1 mole, all the given substance or gases or any substance, if I take 1 mole of any gas, or any substance contain 6.02 into 10 to the power 23 molecules here. This is CH4. Each particle is molecule. So these are the number of molecules of methane that are reacting with oxygen, that is 2 into Avogadro number 6.02 into 10 to the power 23 molecules, right? So you see here, 1 molecule need 2 molecules, 1 mole molecules need 2 mole molecules. 1 mole molecule contains 6.02 into 10 to the power 23 molecules. 2 mole molecules contain 2 into 6.02 into 10 to the power 23 molecules, right? These, the molecules in this ratio, they react completely to produce 1 mole. Again here you see 1 mole CO2, or let's write 1 mole CO2 here. 1 mole contain 6.02 into 10 to the power 23 molecules of CO2, and here 2 moles, we write 2 moles, so 2 into 6.02 into 10 to the power 23 molecules of water. So we can also write, because whenever a chemical reaction takes place, 1 molecule, 2 molecule, 10 molecule, it doesn't take place. It's a bulk phenomena. In bulk number of molecules, in extremely large number of molecules participate in chemical reactions, and this is a convenient method, a convenient way of expressing their quantities in terms of moles. 1 mole methane contain 1 mole molecules of methane, which is Avogadro number of molecules. It reacts with 2 mole oxygen, 2 mole molecules of oxygen, 1 mole CO2, 1 mole molecule of CO2, 2 mole water. It's 2 mole molecules of water. Is it clear? And so this is moles. You have already learned in 9th class what is meant by mole. So I am giving you the definition of mole once again here. What is mole? Mole is a amount of substance that contain Avogadro number. Avogadro number means 6.02 into 10 to the power 23 particles. That contains amount of substance that contains Avogadro number of particles. What are these particles? The particles can be atoms, or the particles can be molecules, or the particles can be ions, whatever it can be, atoms, molecules, ions, they all called particles. So what is mole? Mole is an amount of substance that contain Avogadro number of particles. And then how can we calculate number of moles? We have different formulae to calculate number of moles. One of the formulae is, okay, number of moles, small n representing given weight of substance by its a gram molecular weight. This is a formula you learnt in 9th class to calculate to calculate number of moles of the substance. Now here in a given chemical equation we understand molecules, moles, number of molecules, and one more thing, since all the substances given are gases, we can also write their volumes. Okay, there is a law called Avogadro's law. There is a law called Avogadro's law, or it's called Avogadro's hypothesis. According to this Avogadro's hypothesis, what gases, right, react in their simple ratio of their volumes. Okay, under similar conditions of temperature and pressure, gases, the equal volume of all gases contain equal number of molecules. For example, you see this is one molecule, we can write this is one volume, right? What is the coefficient, stoichiometric coefficient here? 1. So 1 representing one volume of gas, here represent with 2 volumes of oxygen. So 1 volume of methane react with 2 volume of oxygen to produce 1 volume of carbon dioxide and 2 volumes of water vapor. This 2 volume can be liters, so we write like this: 1 liter reacts with 2 liter, produce 1 liter CO2 and 2 liter H2O. Or else we can also write in milliliters: 1 milliliter of CH4 reacts with 2 ml of oxygen, produce 1 milliliter of carbon dioxide and produce 2 milliliter of water. Okay, these are the in different information, different things we understand from a balanced chemical equation. Now you see, if I write simply a word equation, methane plus oxygen gives rise to carbon dioxide plus water vapor. If I write a word equation like this, we can't understand all this information, and this is only possible from the balanced chemical equation. We can calculate molecules, moles, weights, number of particles, and volumes of the gaseous substances involved in the balanced chemical reactions. And now let us discuss few example problems on this type of calculating weights required, calculating volumes produced or volumes required, calculating number of molecules involved in the chemical equation we can calculate. Based on this, we have few problems which are very important for your board exams. That we will discuss now. So now in this chemical equation, the stoichiometric quantities are mentioned, right? You see, 1 mole of CH4 weighs 16 gram, 1 into 16 gram, one coefficient and 16 gram. 2 molecules are 2 moles each into 32 grams, 1 mole into 44 grams, 2 mole into 18 grams, right? These are the stoichiometric quantities of these reactants and products. Okay, now if you're asked a question, right, which means 16 gram methane needs 2 into 32, it's 64 gram oxygen and produce 44 gram carbon dioxide and 36 gram water. 36 gram water vapor is produced. This is we understand from the balanced chemical equations, right? 16 gram methane needs 64 grams of oxygen. Now for example, I wants to know, if I take, instead of 16 gram, if I take 4 gram methane, I have how much? 4 gram methane I have. Okay, then we need to calculate what amount of, okay, it needs what weight of oxygen. Okay, this is a question. Then we can calculate the amount of oxygen needed, okay, to burn 4 grams of methane, right? For this we do, from this stoichiometric equation, what is it? It's like 16 gram CH4 from balanced chemical equation. I'm writing it from balanced equation. I'm writing this 16 gram CH4 needs 2 into 32, right? 2 into 32, or else we can also write it as 64 gram, right? 16 gram methane need a 64 gram oxygen for burning. Then we are given 4 gram. 4 grams of CH4 needs a what weight of oxygen. Let's say this is weight W, right? And this W we need to find out. So how do we find out? We just cross multiply the weights. Okay, these two are cross multiplied and these two are multiplied. So that what do I get? I get W is equal to weight into multiply weight into 16 grams of methane is equal to 4 grams of methane into 64 grams of oxygen, right? I want this W is equal to 4 gram into 64 gram by 16 gram. Yes. Now gram get cancelled. 16 ones are 16 fours are, right? 64. W is equal to 4 fours are 16, right? 16 gram. Okay, 16 gram is the amount of oxygen required. So 16 grams of oxygen is needed for 4 grams of CH4 for complete combustion.